All right, now that we've finished assignment 6B1, the next day, tomorrow in class, you'll see this. You can write the formula. You can have pi radians is equal to this. Our familiar unit circle, you can label it with distances and coordinates. And then the new from last assignment was sine of s is equal to what, and cosine of s is equal to what, and it's what comma what. And here's the answer. Sine of s is equal to v, cosine of s is equal to u, and then it's u comma v. So there it is. The more you can just rely on your memory for these things and not have to compute them and figure them out, the more brain power you'll save for doing for higher level calculations or things that require you to know these facts. Okay, so section 6.22, the sine and cosine function. So check this out. We've got our unit circle, and we've got these different points on the unit circle. And if you go a distance of pi over 6, you'll have this height and this. I just want to focus on the heights. So here's the height, here's another height, here's a height, and you go all the way up here, and it's at a maximum here of 1, the height of 1. And then it goes back down to 0, and then there's no height right here above the u-axis. And then here it's even negative heights. Negative heights, it's down, it's below the u-axis to a minimum of -1, and then back up again. If you were to just focus on the heights and plot them as a function, let's say let the x-axis be the distance around the unit circle. We recognize all these pi's and all these fractions. And then let the y-axis be the height. Let it be the v values, the vertical values. Then you can see it starts at 0, goes up, 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 up till it hits a maximum, and then goes back down again. And then it goes negative, and then goes back up to 0. So actually, these colors correspond to locations on the unit circle. So this is 0, the gray, the pi over 4 is gray, orange here is next, and then brown is next. Green is over here, pi. I didn't highlight it over here. But you get the idea. If you have an input of 0 radians, and radians is what we'll call those distances around the unit circle, if you have a distance of 0, then the output, the v value, the vertical height of that point is 0. The vertical height is 0.71 here. It's hits a maximum of 1 here, and then starts to go back down to 0, and then even goes -1 all the way up to 0. And I filled in some more points here. These are all the different points that we have from the unit circle. This is from a 45-45-90 triangle. This is from a 30-60-90 triangle, 30-60-90 triangle. You get the idea that you can see here, we're plotting these v values now. If the sine function takes as its input the distances and takes as its output the v vertical values, and they get plotted here. If you go in the negative direction, like say you start here and go in the opposite direction, then a negative pi over 6 would be here, and negative pi over 4 would be here, and then you get a minimum of -1 when you've gone a quarter of the way around the unit circle. A quarter of the way around the unit circle goes here, and then eventually back up to 0, and then it continues up again. That's the sine function graphed on its own. Y equals sine of x. So one thing I wanted to say first of all is that I've been to Rocky Mountain National Park in Colorado. Let me know if you've been to the same national park. That's Rocky Mountain National Park. Great place to go climbing, hiking, and just looking at mountains. It's awesome. All right, so over here, what I wanted to say is this top part of the table starts at 0 and goes to positive 2 pi or positive 360 degrees. I'm just graphing the first half of that, so from 0 to pi. From 0 to pi. And if you zoom out a little bit, it would be like this first top part, 0 to pi, but then it continues to go down underneath like that in this same shape here. This bottom row is from 0 to -2 pi, and we'll graph 0 to -pi here. So you can see this, if you go in the negative direction, this is what it looks like. Zoomed out a little bit, it's this first part and then continues up like that. It's a big wave. It goes up and down and up and down and up and down. Let's do the same thing with cosine. So you can see here, there's the unit circle, and we start here at 0 degrees, and if you go when you start with the 0 degrees, you're at a u value of 1. So the input is 0, the output is 1. And then as you go to pi over 2, eventually you go down to 0, because the horizontal distance goes from 1 all the way down to 0. And then it goes negative, down to -1, and then back up here to back to 0, and then back up to 1 again. If you want to look at that, you can graph these horizontal distances over here. Again, when the unit circle is 0, this is cosine. So when the units, if you had a distance of 0, then the u value is 1, and then you can only go down from there to 0 at pi over 2, down here to say negative 0.71 on the table would be this right here, or this right here in brown, to all the way down to a low of -1, like the lowest possible y value is the lowest possible u value, which is -1. So the output is it gets as low as -1. And then zooming out just a little bit, you can see it goes from 1 down to 0, down to -1, and back up again. This is a full 2 pi in either direction. And here are some negative values. If you have the input in radians, or the distance traveled here, it goes in the negative direction, then you can see we have 0 degrees, then down to negative pi over 2, which would be here in blue, giving you an output of 0. Oh, this should be a u right here, not a v. And then here -1 at negative pi pink here, and then it'll continue back up again to 0 and up to +1. That's what the cosine function looks like. So we can see here the function. Because it's a function, we can talk about all those things we know about functions. All functions have a domain. The sine and cosine have all real numbers as their domain, because any real number can have a distance around the unit circle. You can have positive distances, negative distances, decimal distances. Any real number can represent a distance going around the unit circle. Is it odd, even, or neither? Well, the sine function is an odd function. You can see it's rotationally symmetric about the origin. I want you to think about what the cosine function is. I will say that it's y-axis symmetric. So what do you think that is? Do you remember from functions? Periodic? Yes, both of these are periodic. And what it means for periodic is that a periodic function is a function where f of x, it is equal to itself for some number p called the period. So in this case, for sine and cosine function, that number is 2 pi. Because you go around the circle 2 pi, and then all of a sudden you get a repeat of all the values. F of x is going to equal to f of x again, just as long as you also add p, which is the period. The period is 2 pi right here. There's also there's another vocabulary word. The amplitude is going to be, in this case, half the range. So the highest y value is +1, the lowest value is -1. So the range is going to be from say the x-axis up to the highest point, which is just 1. In this case, or you could say from 1 minus -1 is 2, and take half of that, it's 1. That's how you find the amplitude. Here's what it looks like for sine to be an odd function. F of x, the sine of function, is going to equal f of -x here. It's going to be the negative f of each other. I want to explain that a bit better. And maybe I'll just start by explaining the identities. An identity is an equation whose solution is all real numbers. So, for example, 3x equals 2x plus x. Like, any number you choose for x is going to satisfy this equation. If x is 0, it works. If x is 1, it works. If x is 10, it works. 3x is going to be equal to 2x plus x. The solutions are all real numbers. There's lots of these identities for sine functions, and they're kind of important. For the sine function, we know that it's periodic, so that sine of s is going to equal sine of any s plus 2 pi, or 4 pi, or 10 pi, or where k is any integer. the sine of negative x is going to equal negative sine of x. This is what it means to be an odd function right here. So when s is positive, you could also say then sine of negative s would be the negative value. They are opposites of each other, like this. Sine of s plus or minus pi is equal to negative sine s. For any value of s, this is true, and for any value of s, this is also true. Some more identities for the cosine function. So it's periodic. It is an even function here because cosine of negative s is equal to cosine of s. So here the u values are the same. Doesn't matter if you go this way around s or this way around s. They're both going to send the same u values. Here, as you can see, the dotted lines. It's an even function like this. Two more identities that are true for all values of s because they're periodic. Anyway, this is kind of ethereal and kind of abstract to think about, but we'll practice it more in class. And bring your questions, and I'd love to help you answer them. For the moment, copy the problem list and do the first problem from assignment 6B2, and I'll see you in class.